Good afternoon. We're going to do the second half of chapter 7. It's July 20th. By the way, it's the 51st anniversary of Neil and Buzz walking on the surface of the moon in 1969. All right, I told you 5 topics. This is number 3. It's called a large confidence interval for the proportion. We've been dealing with means the whole time, but you've all read a news poll, I would say in the newspaper, but we don't read newspapers anymore. But you read polls, right? Donald Trump's approval rating is 38%. And then you read the bottom, margin of error, plus or minus 3%, because this is based upon a poll of 956 likely voters, blah, blah, blah. Guess what that is? That's a 95% confidence interval for the proportion. And I've written it right here so that you can see it, okay? So let's talk about this. It's the same idea, except we're talking about a proportion and not a mean. The proportion is the same thing. It's a fancy word for a percentage. Let's say that we asked exactly 1,000 people, do you like Donald Trump? And 450 said, yeah, I like Donald Trump. So that's 450 divided by 1,000, you get 0.45, right? That's the proportion. That's the probability that the person will say yes to that question, okay? So we have a population proportion, going with the little Trump thing here, okay? We don't know how many people in this country like the president or not. We can get a sample proportion, okay, and maybe get an idea, but remember, that sample proportion has to be representative, accurate. I'm not so sure that polls these days are very good anymore because people are kind of jaded and sometimes they just say the opposite thing just to screw stuff up, whatever. Okay? But there's a true P out there, a true proportion. Okay? But we're only going to get the P hats. Okay? We're obviously only going to take one of them, but there could be many of them and they would spill out over this hidden thing here. The thing is, we don't know where it is, but we know that there's a bell-shaped curve over the top of it. It's a beautiful concept. Okay? So population proportion P, sample proportion is pronounced P hat. Did I write that up here? Yeah. Called P hat. Okay? Now, let's say we're doing 95%. If you go back to one of the previous video or the one before that, I can't remember if it was in 6.2 or 7.1. I wrote down confidence levels, 80, 90, 95, 98, 99. And then I wrote down 1.282, 1.645, 1.96, 2.326, and 2.576. That's, if you went out that far on a bell curve, that's how much of the bell curve you would cover. Okay? So, I'm going to use 95 just as an example right now. "95% of the p-hats would fall within 1.96 standard deviations of the true proportion. Therefore, using my cast net analogy for Southwest Florida, you have a 95% chance of falling in this region. So if you fall in that region, boom, like right there, and you go out that same 1.96 in either direction, guess what happens? That interval will contain the true population proportion P. Okay? So that's how it works. Here's the scary formula down at the bottom. You don't have to do it by hand. Your calculator is going to do it for you under stat test A, 1 prop Z int. And I'll have that on the other side of the board, along with some cool artwork I just did for you. All right, so it's an estimate plus or minus an error. Estimate plus or minus an error. That's what a confidence interval is. Remember, it was X bar before plus or minus the Z and the standard deviation. Well, here's your Z. It's the same as before. If I say 95%, you know 1.96. And then we use this part, the square root of P hat times Q hat divided by the sample size. Q hat is nothing but the complement. So if P hat is 0.6, Q hat is 0.4. All right? So I'm going to flip the board around and we're going to do an actual problem. And then after that, we're going to do minimum sample size, which is very straightforward. It's very simple. There's no magic button on the calculator, but the formulas are exceedingly simple, and you can just do it by hand in the calculator, okay? Look at that artwork. July 20th, 1969. We came in peace for all mankind. Tranquility base here, the eagle has landed. By the way, Neil was actually taller than Buzz, but my artwork's not that great. Looks like MTV, doesn't it? I don't even play that song anymore. I don't even play songs on MTV anymore. MTV came out when I was a senior in high school. I believe it was August 1st, 1980. And we just sat around and watched TV all afternoon because it's like, it was so cool. It's hard to explain how cool it was. All right. Neil and Buzz have to go away. I need space. That's great. All righty. An example. Candidate Susie. You know, we had little Johnny before. Now we have candidate Susie. She has a poll commission because she's running for office. She's already in office and she wants to see how she's doing. And we get the following results from this poll. And of course, in theory, the poll is representative. Sample size 1,000. I'm just trying to make the math easy. Susie gets 510 yeses, and her opponent gets 490 yeses, you know, saying I support the opponent. Question is, how shaky is she? You know, that they're only 20 apart for 1,000. Let's see what happens. Well, you can use the formula by hand. It's no problem. Okay. Make sure when you use it by hand, you read the instructions in the homework so that you don't miss the question. All right. If it says to 2 decimal places, 2 decimal places. If you do it to 3, even though it's more accurate, it's a computer. It's not a human being. It doesn't have a mind. There's no such thing as artificial intelligence. Okay. That's Alexa. It's not a real thing. Okay. Alexa is just Google that talks back to you. And by the way, Alexa's wrong on a lot of things because it just picks the top thing. You can Google, Alexa, what is the population of Cape Coral? And it'll tell you the 2010 census. It's 2020, and we're doing the census now. Cape Coral's fastest growing city in America. It's not going to be even close. So you hit stat, you go to test, you go down to A, one prop Z interval. It's pretty straightforward. And you know what I did again? I forgot my calculator. I'll be right back. I'm here. Here we go. So, stat, test, go down to A. Oh, I should have left it there. Hang on a second. Let me do it over again so I can show it to you. I'll talk loud again. I apologize. I mumble. I'm a mumbler. There we go. See that? And there you go. It asks for the raw numbers. And what do we have up here? We have the raw numbers. We care about Susie. All right. She's X. We could do it for opponent. We could call that person X. It doesn't matter. The thing will work out the same way. 510, 1,000. And all political polling is done at 95%. Doesn't mean that in my homework it's going to be 95%. I need to test you. But if somebody produces a poll and they publish it, it's always a 95% confidence interval margin of error. So there's all the information. Grandma's coming out right now. Might have to stop for a second. And there's the answer. I'm going to round that off. All right. So that's 0.48 to 0.54. Mother, can go sit right over there, and I'll put the TV on in just a few minutes. I need a few more minutes, though, okay? All right. Mom gave you a shout out. All right, so there's the answer. So there's a 95% chance that the mean is between 0.48 and 0.54. That's a pretty big spread. She's looking better than her opponent. If we did it for the opponent, it would be more like 0.46 to 0.52. That's what it would come out to be. You can check it yourself. All right, so there's some overlap. But you've seen, watched TV, read it yourself, and maybe a news article. Well, the poll is too close to call because it's within the margin of error. Well, that's technically true. They're overlapping, but Susie's overlapping towards the good side, and opponent is overlapping towards the not so good side. So yeah, but never trust a journalism major to get it right. Always trust the mathematician. Okay, they overlap, but just because they're within the margin of error does not mean that the poll can't give you a positive answer on that. There's some higher level mathematics that we use to tell you the probabilities of each one, but that's not in this class. So if you can do that, you're good to go. I'm going to erase both boards, and we're going to do minimum sample size here real quick. And there's no magic button for minimum sample size. You just plug it in the calculator and do it. All right, we're going back to the mean. Minimum sample size for the mean, whether it's a large or small, doesn't matter. There's our formula for number one and modified version for number two. Remember, X bar is an estimate. Anything that's an estimate, by definition, has error in it. What if you knew how much error you were willing to live with at a particular confidence level? Z represents your confidence level. E represents the amount of error you're willing to live with. If you know the amount of error you're willing to live with, the confidence level you want, and you know the standard deviation, you can use algebra to solve for n. I'm just going to go skip the algebra because you're not going to actually have to do it, but I know you all better know your algebra, okay? There's your formula, okay? That's the minimum sample size for mu. Let's do a simple problem. There you go. Let me stand over here. We want to know, we want to be within zero 0.5 inches on the height of men on this planet. We know that the standard deviation is 2.5 inches, and we want to know it with 95% confidence. Again, if we're buying pants for the Marine Corps, a half an inch is close enough. You don't need to be any closer than a half an inch. So why would we want to worry about minimum sample size? Think if you were the Mercedes-Benz Corporation. They're required by law to smash cars into concrete walls with crash test dummies in there. Do you think they might want to crash as few as possible? Right? Does the Marine Corps want to measure 20,000 guys when it can measure 100? Let's find out what the answer is. Dear Aunt Sally will take care of the rest from there. You don't have to have any internal parentheses because it'll do the division or the multiplication on the top before it does the division. So here we go, here we go, here we go. Remember the 1.96 is for 95%. There it is. You see it? You can. And I get 96.04, basically 100. Now, this is important for your homework. Pay very close attention so you don't use up your 6 tries. It's kind of a semantics thing, but it's like if you want to sound like an educated person, you don't walk around and say ain't all the time, okay? Sometimes I talk that way, and we all do, but if we're in a serious situation, math being a serious situation, we want to be proper and use correct form. Can you measure 0.04 of a human being? No, you cannot. So if you have any decimal place, unless this number is an integer, whatever that number is, round it up. Not if it's 96.5, you round it up. You round it up if it's 96.04. Always round up, and you can use it to spray for weeds in your flower beds too. It's a good joke. All right, so we're done with that. I'm going to erase the board again. I'll stand back for a second. You got it? Okay. If you like pina coladas and getting caught in the rain, if you're not into health food, if you have half a brain, minimum sample size for this one is going to have 2 separate formulas. I'll explain it here in just a second. I'm going to skip the derivation of it. In class, I would give you the derivation, and I might make you answer questions on it. We just don't have that capability now. So what we're doing in this class is we're learning hard basics. Okay, hard basics will get you through because you would have forgotten 50% of the hard stuff anyway. So we're just trying to keep it real. We have 2 separate cases: no info and previous info. That's the smallest formula in the world. You just got to plug in 2 numbers: your confidence level and your E. Where did that 1/4 come from? When we multiply those 2 numbers together, the sample proportion and its complement. 0.25 times 0.25 is the largest value that you can get from that. For example, think about it this way. If something's nearly 50-50, like with Hillary and Donald last election, very, very close, all right? Let's say that it's 50.2 to 49.8. Who cares who's ahead or behind? You're going to have to ask a whole lot of people before you know for sure what's going on. But look at this other one here. What if I went around my virtual classroom and said, hey, do you like ice cream? Yeah, I do. Hey, do you like ice cream? Yeah, I like ice cream. Blah, blah, blah. And I go down, and the first 12 people say, I love ice cream. And by the time I get to the 13th person, I finally find somebody who says, I'm lactose intolerant. But I still kind of like it. I just can't eat it. Right? We can figure out very quickly when something is spread 90% to 10%. But when they're really close together, we can't. And if you're doing something where you have no information on it, you have to use the worst case scenario. So there's your formula. So now do you get it? They're the same formula, but here, if you already know, for example, if you know something has a 95% probability on average historically, you want to see if it's changing, okay? Or something has a very small probability, like 5%. You want to see if it's changing, okay? You can you can you can use this, all right? When I give a test, I only use this formula, but I think there are some problems in your homework that will require you to use this one. So we'll do it both ways for finding out a poll with a margin of error of 3%. There's our question. At 95% confidence, how many people do we have to poll to get within plus or minus 3%? All right. If we have no other information, we're going to use this one. I've done this problem so many times, I already know the answer. It's 1,067.11111 repeating forever. So you have to ask 1,068 people to get plus or minus 3% probability or plus or minus 3% error at 95% probability. All right. Let's say that from a previous poll, we're doing something not Hillary and Donald, but we're doing something that's more like a 90-10 thing. Let's say the Ice Cream Association of America wants to find out if people are not liking ice cream as much because of the COVID virus or something like that. I don't know. I'm making it up. And from previous polling, we know that it's 90% like it and 10% don't like ice cream. Now, intuitively, you should know that when something is obvious, you don't have to ask very many people before you find out, yeah, it's obvious that people like ice cream. So this number is going to be much smaller than 1,068. Bear with me for a second. I did the multiplication at front in my head. It's 0.09. That's 0.1 times 0.9. Look at that. You only have to ask 385 people. There you go. All right, folks, that ends chapter 7. Tomorrow or the next day, you'll have chapter 8. By Sunday, you'll have everything. So you'll have a whole nother week. I see people are watching the videos. Please do the homework, all right? Don't mean to harp on it, but only about half of you are keeping up with it right now. I need you all to pay attention. I don't want anybody to fail, okay? But I have to uphold standards, all right? You understand that? See you next time.